Brr. So in the poles, we have sea ice. Sea ice forms over the ocean, and there are different kinds of it. It starts to form as a thin sheet of ice. Then wind can break up that thin sheet of ice, and it can form these little um, islands of ice that are called pancakes. This is pancake ice. Those pancake ice chunks can refreeze and become an ice floe. So this one is a refrozen ice floe. There are other different kinds of ice. This is the edge of Antarctica, and we'll go over some of them. There's fast ice. Fast ice is ice anchored to a landmass or shallow continental shelf. So it's held fast onto the land. That's fast ice. It's not moving fast. It's just stuck to the land, fastened to it. There's drifting ice. So the drifting ice is ice that's floating freely in the water. And there's pack ice, continuous or nearly continuous sea ice. So different kinds of ice. And when a piece breaks off, that is an iceberg. These are big. Pancakes would be the small ones. An iceberg would be the big ones. Massive, irregularly shaped. About 12% of their mass is above the sea surface, but then another 88% below the sea surface. Castlebergs and tabular bergs, these are different ones. Castle ones are big, tabular ones are kind of smaller. These are mostly in Antarctica, Greenland, and then calving off of glaciers in Alaska. All right, the atmosphere, it has layers. And you've probably heard these names before: the troposphere, the tropopause, the stratosphere. Well, the tropopause is the layer between the tropopause and the stratosphere. And then above the stratosphere is the stratopause. And then the mesosphere, the mesopause, and the thermosphere. So if we start down at the troposphere, that's where we live, the temperature decreases with altitude. And maybe you know this if you've hiked up a mountain. It gets cooler as you go up. And this is going to then go to the stratosphere, which increases with altitude. So it has ozone in it. It absorbs solar radiation and then warms as it goes higher. And then we get to the mesosphere, which is losing heat, and the temperature is decreasing as you go higher. And then the thermosphere is going to extend out into space, and the temperature also is going to change as it gets closer out, as it gets, I guess, closer to the sun and out into outer space. So those are the layers. They are, I guess you can see, they change names by, are they decreasing or increasing in heat? So just, I want you to know that. All right, the atmosphere, what is it made out of? Well, there are kind of two classifications of gases here. The first one are the permanent gases. That means that the percent volume of them pretty much stays the same in the atmosphere. The ones that are variable are the ones at the bottom. So let's go over to this graph here. Most of the atmosphere is nitrogen and then oxygen. So almost 80% nitrogen, 20% oxygen, and then the other are like argon, neon, helium, hydrogen, and xenon make up the rest of what we think of as air. There's also suspended particles, microscopic particles in the air. I can, like, do this and get dust off my shirt, and I can see little dust particles in the air, right? And there's also water vapor. So there are, though, these variable gases, water vapor, carbon dioxide, methane, nitrous oxide, and ozone. And some of those are put into the atmosphere by, like, volcanic eruptions or anthropogenic inputs, or methane, some release of hydrocarbons, and then also pollution as well. It releases those into the atmosphere. So those are the ones that are variable versus the permanent ones above. All right, those gases in the atmosphere are touching the ocean, and so the ocean absorb some of those gases, either by just an exchange along that surface or by wave action incorporating gases down into the ocean. So the gas has lots of dissolved gases. The ocean has lots of dissolved gases in it.